Okay, so these are the steps we take to graph something that's not in vertex form, not in shifted form, if we're not going to complete the square. You actually might like it better than having to complete the square. So, first of all, we find the vertex. That is going to be, we need that because then we have an axis of symmetry to work off of, and that will help us get points really easily. So, to find the vertex, you use this formula, the x value of the vertex, that is. Now, think about it. The vertex is some xy value on the function that is either the maximum or minimum, right? It's an xy value. That's a vertex. So now this is how you find the x value of the vertex, this formula, negative b over 2a. Not to be confused with the completing the square formula, b divided by 2 squared. You can't confuse them. So let's find the x value of the vertex. Looking here, ax squared plus bx plus c. So take and do negative b, that means the opposite of b. So wouldn't it be positive 2? 2 divided by 2 times a. My a is 1, isn't it? So that would be 2 over 2, which is 1. Okay, so the x value of my vertex is 1. Now think about it. Look. 1, but then it's like, well, where do I go? Do you guys see why we are now stuck? Well, how do functions work? Can't I plug in something and get out something? Yeah, plug it in for x. So here we go. 1 squared minus 2 times 1 minus 3. So that'd be 1 minus 2 minus 3, isn't it? Negative 4. So my axis, my vertex is over 1, negative 4. Great. Now that is my minimum or maximum value. It's a minimum because it's a smiley face because our leading coefficient's 1. That's my minimum value. Now to help me graph easier, I'll draw in an axis of symmetry because then if we know a point on this side, we know a point on this side since it's symmetric. So then from there, we're going to plot some other points, but we're going to pick specific points like x-intercepts. So the x-intercepts are where it crosses the x-axis, which are the solutions when you solve the quadratic. So to solve a quadratic, we solve by factoring. If we have to use quadratic formula, let's not pick those points. Do you guys see what I'm saying? So let's factor it. Well, multiplies to be negative 3 and adds up to be negative 2. 1 times 3, negative 3. They quick factors to be x plus 1 and x minus 3. So x equals negative 1, it crosses at negative 1, and x equals 3, it crosses at 3. So I'll plot that point. Negative 1 and 3. Now look, are they symmetric? Your x-intercept should be symmetric over the axis of symmetry. You guys see how it's 2 units to that x-intercept from the axis of symmetry? 2 units to that, so we're good. Now find the y-intercept. We're just, like 3 points is not enough. That's not enough points to like graph an accurate graph. So now pick some more points. We're also going to pick the y-intercept because that's way easy every time. The y-intercept is always when x equals 0. Now go to this function, 0, 0, right? So it's going to be negative 3. 0, negative 3. Somebody asked me last hour, is it always going to be that constant? Well, yeah, think about y. When we plug in 0, won't that get rid of our x's every time? Yes, so it will be the constant. 0, negative 3. So now look, I have plenty of points now. Over 0, down 3. Because why? Well, I'm going to use the axis of symmetry to plot one more point. Over 1 unit, so over 1 unit. Now I have 1, 2, 3, 4, 5. 5 points is all that's required, really. Doo-doo. Easy. It's just plotting specific points. Okay, here we go.
How do we know our mean is 1?
Because we use that formula negative b over 2a. So let's do another one. So you would have to know that. It says graph. So you'd say, okay, so I'm going to first find my vertex. It's not in standard form, and I don't want to complete the square. So x is equal to negative b over 2a will be the x value of my vertex. So it'll be positive 6, because negative b would be opposite of b. And then over 2 times 1, so that would be 3, wouldn't it? 3 comma, well, let's figure it out. 3 squared minus 6 times 3 minus 7. So that'd be 9 minus 18, right? Minus 7. So then that would be negative 15. Negative 16, which is off my graph, which, okay, that's fine. Over 3, negative 16, so it's just somewhere clear down here. So this is what you would do on a test. You would just say, okay, it's clear down there somewhere. Can't fit it, but that's okay. Alright, so now we'll find the x-intercepts, because we need more points to plot. So you'd say, okay, my x-intercepts are when I solve it. So it multiplies to be negative 7 and adds up to be negative 6. 1 times 7, negative 7. It factors to be x plus 1, x minus 7. So it's crossing at negative 1 and 7, isn't it? So I go -1 and 7. Now look, it should be symmetric over the axis of symmetry. 1, 2, 3, 4. 1, 2, 3, 4. All is good. We now have 3 points. That's not enough. So let's find the y-intercept. The y-intercept is always when x equals 0. So then we'd have 0, comma, -7, right, everybody? So 0, -7, and now I can use that to plot over 1, 2, 3, 1, 2, 3, and now I have enough points to connect the dots. Not too shabby. Okay, another one, there's a reason. So let's find the vertex. So you'd say x is equal to -b over 2 times a. So isn't that 6 over 4, which is 3/2? Decimals are always easier. So 3 divided by 2, isn't that 1.5? So we'd say, okay, 1.5, comma, and then you would plug 1.5 in. 2 times 1.5 squared minus 6 times 1.5 minus 3. You would calculate it and you would get 0.5. So look, over 1.5 and then up 0.5. So that'd be right there-ish. So it is kind of not the prettiest point, but that's okay. Let's find our x-intercept. So let's see if it factors. Did we forget all of this? Because I'm feeling like this is a smiley face. Do you agree? So will it have x-intercepts if that's our vertex? No, but I thought I created this problem to have x-intercepts. So let's see. Does it factor? Well, it multiplies to be -6 and adds up to be -6. Nothing. So it doesn't have x-intercepts. So that's okay though. So we're not going to be able to find x-intercepts. So then find a y-intercept. The y-intercept is when x equals 0. So then that would be 0, comma, -3. That can't be. Can it? Because then it's going down, and then it would cross the x-axis. Oh. What in the Sam? I'm so confused. What am I not seeing?
Sam.
Poor Sam.
Because I was going to say, if it flips upside down, it will have x-intercepts.
Yeah.
What am I not seeing? Can anyone see? Where did I mess up? I've messed up, even though I made...
-6, -5.
6. Is it negative what?
0.5.
Oh, maybe that's what it was. I don't... Maybe... Okay, maybe that's the problem. Maybe we need to calculate... Maybe I calculated that wrong. Somebody type that in. That's got to be what it is. Sorry. I swear last hour I like this one. I was remembering from last hour and I swear they said. Okay, -7.5. That's probably better. So then we're going over one. That is so much better. That is so much better. Okay. So over 1.5 down 1, 2, 3, 4, 5, 6, 7.5. Okay, it's right there. Now that makes sense because our y-intercept, so it actually will, so even though it doesn't solve by the quadratic formula, even though it doesn't factor, we could solve with quadratic formula. But then if we need quadratic formula, won't that give us decimals?
Yeah.
I don't want to use those points. So I'm going to move on. I'm not going to choose to use the x-intercepts on this one. You can choose to use whatever points you want. So then from there, 0, -3. So then over 1, 2, over 1, over 1.5 actually, over 1/2 and 1. Right there. There it's symmetric. Now we need a couple more points. I'm not going to do x-intercepts. It is going to cross, but it's going to be at a decimal. So then from there I'd say, okay, I'm going to pick some more x, y points. I'm going to plug in -1 or plug in a 4. Plug in a -1 and then we can plug in any point and then it will be symmetric. So I can plug in -1 and get out a y value. But we get the picture here. There it is. Okay. Alright. I don't think we need another one, do you?
After the last one.
It was a little weird. So, okay, I think we're probably good. Okay, so let's just read this one. Determine if the function will have a max or min. Because honestly, essentially with these, can't we just plot a bunch of points? Once we have the vertex, just plot a bunch of points. You do have to be able to find the vertex. Okay, determine if the function will have a max or min value and then find that value. Okay, tell me. Will this have a max or min? A min, isn't it a smiley face? Okay, so it's going to have a min, so that's what you'd write on the test. It has a minimum at, well, you got to find the vertex. So you'd say x is equal to negative b over 2a, so negative 12 over 2 times a. So then that's negative 12 over 6, which is negative 2, right? Negative 2, comma, well, you got to plug in negative 2. Somebody with a calculator. 3 times negative 2 squared plus 12. More than one person, because once again, we're figuring out that some of these calculators have weird things going on. Our min is at yep, that is correct. Negative 2, negative 19 is our min. Easy, right? So looking at this one, is it a max or min? Let's see. It's a frown, so it's a max. You'd say we have a maximum at x is equal to negative b over 2 times a. So that's negative 10 over negative 2, which is 5 comma, and then you'd plug 5 in. Negative 1 parentheses 5 squared plus 10 times 5 plus 8. That negative is not with x, right? We know that. That's just like having a negative 2 in front. Plugging in 5. That'd be negative 25 plus 50. 25. So 533 is our maximum. Okay, easy. Okay, now let's do these 2 story problems. Super easy stuff. It really is. So everyone listen though, because I had a lot of people not understanding, and it's seriously, you should not miss these ones on the test. They're not hard. It says, suppose a marketing department for Dell Computer has found that when a certain model of computers is sold at a price of P dollars, the daily revenue as a function of the price is as such. So they give you a formula. So then say, what does P stand for? Price, and then R is the revenue. Correct, everyone? How do functions work? I plug in a price and I get out some revenue, right? Input, output, X, Y. Do you agree? Yes. Okay. It says for what price, does not mean for what P? Yeah. For what price will the revenue be at the max? Do we know how to find a max? Yes. Find the maximum, and that's your answer. So let's find the maximum value, everyone. So that's our vertex, because this is a frowny face. It's just asking us literally to find the maximum. So you'd say x is equal to negative b over 2a. So then that's negative 400 over 2 times negative a fourth, which if you calculate that right, you should get 800. Isn't that the p? Isn't x p? What price? So you'd say it's 800. 800 was the price. So at $800, and then it says, what is the max daily revenue? Isn't... Plug in 800, so you have negative 1/4 times 800. I need everyone to type it in, because all day we have not had people be able to agree on an answer. So I'm curious, because I'm videoing this hour, for people at home to want to make sure their calculators are on track.
Positive 160.
$160,000. So at $800, they're making a max revenue for that day of $160,000. Okay, awesome. Okay, one more. This one you want to write down, because this one, I'm telling you, you need to know it. Okay. A farmer has 300 feet of fence to enclose in a rectangular field. What is the maximum area that can be enclosed by the fence? And then what are the dimensions of the rectangle that is enclosed in the most area? We don't want to guess and check, because there are so many ways to do this, like guessing and checking. You might not realize it, but there are so many. So there are so many answers. So that would guess and check. Only one works. So we draw a rectangle. It says the farmer has a total of 300 feet of fence. So isn't all of the sides add up to be 300? So then it does not even, in this particular problem, it doesn't give any information on length versus width, does it? So you would say, okay, we know nothing about length. We know nothing whatsoever about width. They didn't say it's twice the length or anything like that. So we got to call them different variables. Now you have two variables, you have to have two true statements. That's always how it works. So my first true statement would be x plus y equals 300. Do you agree? Yeah. 2x plus 2y equals 300. There's our first true statement. Now the next true statement for a rectangle, the only thing we know is that length times width equals area, right? We don't know what the area is. We're asked the max area. So you'd say the other true statement is x times y equals area. So now from here, it wants to know how can we split this up so that we get a max area. It's asking you to find the maximum of the area. Well, first of all, is this a quadratic? Maximums come from quadratics. Is this quadratic? No, it's linear right now. Well, we can't have two different variables, can we? So don't we need to use substitution on using this, where we can then plug in and only have one variable? Yeah, let's do that. So solve for a variable. Solve for x or solve for y. It doesn't really matter. Solve for y, someone said first. So subtract 2x. Subtract 2x. 2y equals 300 minus 2x. You're solving for y. Divide by 2. So then we have y is equal to, as long as you divide both of them by 2, it's okay. 150 minus x. Well, now look at that. Let's take and plug that in wherever there's a y. So now we have x times by 150 minus x equals area. So distribute that in. We do have a quadratic, it turns out, after all. We have 150x minus x squared equals area. Isn't it asking us to find the max of the area? So find the maximum. And then we'll find our max area. So you'd say, okay, our quadratic is negative x squared plus 150x equals area. So find the max. You do negative b, so negative 150 over 2 times a. So that's negative 150 over negative 2, which is 75. Isn't that the input? Don't we need output if we want area? When we plug in 75, we're going to get out a max area. So how do we get, so we got x is equal to 75. So don't we have 75 comma, we don't know? So plug in 75 back right here. Everyone do it, or right here. I want a solution from many of you. It's big. Yes, that's it. 5625. So the maximum area is 5,625, everyone. So we've answered the max area. So then from there it says, what are the dimensions of the rectangle? So go back and say, okay, so isn't it true that we found x is 75? 75. So then plug it in. You'd say 75 plus 75 plus y needs to equal 300, and then solve for y. So if we do that, then we get y is also 75, turns out, in this particular problem. So it was a little harder to set up, but we can do it. What I want you to do now is, for the rest of the time, go pick some of the story problems in this section. Yeah, and then go, graphing is easy. I mean, for the most part, find the vertex and then plot any point on it. I don't care what point you plot, honestly. Plot points and draw a U. You do need to find the vertex. That should be your starting point.